Hello. Yes, we welcome you back to PSSB Physical Sciences Silver Bullet with me, Richard here. Today we are looking at this question. It says that 12.8 grams of sodium hydroxide is dissolved in 300 cubic centimeter of water to make a standard solution. Okay. Now, 60 cubic centimeter of this solution is used to neutralize 30 cubic centimeter of solution of ethanoic acid. And the question says that name the suitable indicator for this reaction and explain. Okay, how do you determine the suitable indicator for this? Okay, you look at what is reacting. We are having this sodium hydroxide as our base. And we are having ethanoic acid as our acid. Now, you check, what is the nature of sodium hydroxide? Is it weak or strong? It is a strong base. And what's the nature of ethanoic acid? Is it weak or strong? It is a weak acid. Now, I need to remind you that it's the strong which takes the pH. So it's the base which is strong, so the medium is going to be basic. So the question is, which indicator works best in the basic environment? Okay. The indicator is phenolphthalein. Yes. So what is the reason for choice of phenolphthalein? The reason is that the reaction is between a strong base and a weak acid. So that's that. Yeah, then we come here and we say calculate the concentration of ethanoic acid. Okay, how do you go about this? Let us analyze the question. We have this mass of sodium hydroxide dissolved in this water to make a standard solution. So which means that we don't know the concentration of the standard solution. So let that one be our first priority, our first task. What are you going to say? Calculating the concentration of sodium hydroxide, the standard. Okay. So we look at the information we have. What information do we have here? Okay. We know mass. The mass is 12.8 grams. We know the volume. The volume is 300 cubic centimeter. Converting it to cubic decimeter, we divide by 1,000, giving you 0.3 cubic decimeter. Okay, what else do we know? Okay, yeah, we are looking for concentration. Okay, when you happen to quote the equation, you can see what is missing. The concentration equation, which uses mass, is going to be C is equal to mass over molar mass times volume. So the equation shows that we are missing molar mass. So what do? We find it. It's going to be molar mass of sodium hydroxide. Okay, which sodium is 23 plus oxygen, which is 16 plus 1, giving you 40. So now we have all the information to substitute in this one. And what are you going to say? We are going to have the 12.8 grams divided by the molar mass, which is 40, times the volume, which is 0.3. So there we are. 1.067 moles per cubic decimeter is the concentration of the standard being sodium hydroxide. So now, after calculating the concentration of the standard, what is the next step? Next step is to calculate the number of moles of sodium hydroxide which reacted. Okay, let us have it here. Calculating the number of moles of sodium hydroxide which reacted. Yes, we calculate it here because we couldn't do it without the concentration of sodium hydroxide. So what do we do under this circumstance? Let us check what we have here for this one. We know concentration, which is 1.067 moles per cubic decimeter. This is what we have just calculated before. Okay? What else do we know? We know the volume which reacted. You have to know that when you are calculating the number of moles which reacted, you use the volume which reacted, and that volume is 60 cubic decimeter. So it's going to be 60 over 1000, giving you 0.06 cubic decimeter. Okay. Then what are we having? We are looking for number of moles. Okay. So from there, you quote the equation. The equation is C is equal to N over V. Okay. From here, what do we do? You know C, which is 1.067. Okay. And our N is wanted. But we know V. V is 0.06. Okay. What do we get here? We are going to have N equals to 1.067 times 0.06. That one will give you the number of moles of sodium hydroxide which reacted. So that is it. We have it here. Now, the number of moles of sodium hydroxide which reacted, I need to remind you that we move from known to unknown. So now we have the number of moles of the known which reacted. Next step is going to be calculating the number of moles of the unknown which reacted, which is sulfuric acid. How do we link this number of moles of sodium hydroxide with the number of moles of ethanoic acid? We use mole ratio. And how do we get the mole ratio? Through equation, a well-balanced equation. So our next step is to now calculate what? Calculate the number of moles of ethanoic acid which reacted. Okay. And how do we go about this? The link is through a well-balanced equation. So we're having sodium hydroxide plus our acid. Okay. This one will give you the salt, which is sodium ethanoate, plus water. The equation is balanced. So from here, what do? You get the mole ratio. This is 1 to 1. Okay? And we know the number of moles of what? Of our standard, which is sodium hydroxide. And the number of moles is 0.064. And if this is 1 to 1, so what does that mean? That the number of moles of ethanoic acid is 0.064. So what is the next step? Next step is to list everything you know about ethanoic acid. Let us have it here. Okay, it is ethanoic acid. Okay. What do we know about it? We know the number of moles, which is 0.064. We know the volume which reacted, and the volume is 30 cubic centimeter. So it's 30 over 1000, giving you 0.03 cubic decimeter. What else do we know? That's all, but we are looking for C. So with this information, what do? We quote the equation. The equation says C is equal to N over V. So what is our N? Our N is 0.064. And what is our volume? Which is 0.03, giving us our concentration in moles per cubic decimeter. So that is that. So what you have here is the concentration of ethanoic acid. It is 2.13 moles per cubic decimeter. Yeah. Then comes this question. It says, state the pH of the resultant solution after neutralization. Write pH greater than 7, pH less than 7, or pH equal to 7. Explain your answer. Okay, so here you have to realize that the initial reaction which took place is between ethanoic acid plus sodium hydroxide, giving you the salt, which is sodium ethanoate. And plus water. Okay. From here, you have to take note that this is the salt which is formed. And this salt is between a strong base and a weak acid. So that's what you have here. This is from the base and this is from the acid. But you need to realize, or you need to know, that ions from strong base or acid are not hydrolyzed. So it's not going, so that one won't be hydrolyzed. So that one leaves us with only ethanoate ion. So it is the ethanoate ion which is going to react with water. So what does it happen? What happens? It reacts with water. And being negative means proton seeking. So water donates a proton. On receiving a proton, you get CH3, COOH, which is ethanoic acid, plus what? Water loses a proton. What happens? You remain with OH. And it is the OH which is the determinant of our pH. So our resultant pH comes from OH, meaning what? Condition is basic. Basic implies what? It means pH is greater than 7. So with that, I would like to say thank you for your time. We urge you to subscribe, comment, like, share. We need to remind you that this channel is a science channel which deals in physical sciences grade 12, 11 and 10, and natural sciences grade 8 and 9. When you are using the channel, we advise you to use playlist instead of video. Just go to playlist and select the material which belongs to your level. For grade 8 and 9, choose natural sciences grade 8 or natural sciences grade 9. For grade 12, for grade 11, choose physical sciences grade 11. And for grade 10, choose physical sciences grade 10. As for grade 12, each topic is presented independently, so choose the topic of your choice and you'll have all the material which you need for that topic. With that, I would like to say thank you. God bless you. See you next time. Bye-bye.